Today we're going to talk about the surface area of cones and the surface area of pyramids. So by the end of this lesson, you should be able to use the formulas to find the surface area of those two shapes. So we have some vocab again to talk about, and it's basically the same words as before except applying them to different shapes. So the vertex of a pyramid is the point opposite the base. The base of a regular pyramid is a regular polygon, and the lateral faces are congruent isosceles triangles. The only ones that we're going to find surface area and lateral area of are regular pyramids. The slant height of a regular pyramid is the distance from the vertex to the midpoint of an edge of the base. So if we look here, if this is one of our isosceles triangles, this slant height is right in the middle of this, and it's perpendicular. So basically, it's the height of our triangles. Height of triangles, which we'll need to find the area of them. The altitude of a pyramid, though, is the perpendicular segment from the vertex to the plane of the base. So it would drop down and sit right here in the middle of this pyramid. A non-regular pyramid has things that are a little funky, like the vertex isn't right in the middle. You don't have isosceles triangles. But like I said, regular pyramids are the ones we're going to deal with. So where these formulas come from is because if you were to take all the lateral areas of this square pyramid, they can cover half of a rectangle. Like this right here and this right here can be those two triangles here. And this length is the perimeter, and this height is the slant height. So that's why when we look for the lateral area, it is 1/2, because it only covers half of that rectangle, times the perimeter, times the slant height. So this is very similar to the prisms and cylinders that we were talking about yesterday, except we have to cut it in half. We find the perimeter, and then we find out how tall it is, but it's the slant tallness. And then the surface area is that lateral area plus the base. And for these, we only have one base to add on to, and it's always going to be a polygon. So let's do an example. Find the lateral area and surface area of a regular square pyramid with a base edge length of 14 and a slant height of 25. So in order to find lateral area and surface area, we need to know two things. We need to know the perimeter, and we need to know the area of a base. So the perimeter is all the way around, and because it's a square pyramid, we know all the sides have got to be the same. So 4 times 14, which is 56 centimeters. The other thing we need to know that they don't give us is the area of the base. And because this is a square again, we know we have 14 times 14, which is 196. Now using this information and the information they gave us, we should be able to find the lateral area and the surface area. So remember, your lateral area is 1/2 your perimeter times the slant height. So 1/2 the perimeter I just found and my slant height they gave me. If you plug 1/2 times 56 times 25 into your calculator, you get a nice even 700 centimeters squared. And now the last thing we got to find is the surface area. Now remember, the surface area is your lateral area plus the area of your base. So 700 plus 196. So that gives me 896 centimeters squared. I'm leaving this one for you to do. The area of your base, though, you might need some remembering. Remember, it's 1/2 ANS. So remember, A is your apothem, which you'll have to find. Number of sides, hopefully you can count those, and then the side length they gave you is 10. So same as before, except the area of your base will be a little harder than the one I just did. So let's talk cones. The vertex of a cone is the point opposite the base, same with a pyramid. The axis of a cone is the segment with endpoints at the vertex and the center of the base, same with a pyramid. The axis of a right cone is perpendicular to the base, and the axis of an oblique cone is not perpendicular to the base. So axis is perpendicular, axis is not perpendicular. We still have a slant height of a right cone, and it's the distance from the vertex of a right cone to a point on the edge of the base. The altitude of a cone is the perpendicular segment from the vertex to the plane of the base. So for a right pyramid, the axis and the altitude are the same thing. But for one like this, the altitude would be this distance here where the axis is crooked. So here's your formulas. The lateral area of a right cone with a radius of r and a slant height L is pi RL. So this right here is how tall your cone is, and this radius determines how much of the circle gets cut out. So the smaller the radius, the less of the circle we need. But the larger the radius, the bigger the circle we need. And then the surface area is just the lateral area plus your base. And since our base is a circle, that's where we get pi r squared from. So find the lateral area and surface area of a right cone with a radius of 9 and a slant height of 5. So our lateral area is pi times radius times slant height. So we just got to plug it in. So we end up with the lateral area is 45 pi centimeters squared. And then the surface area, we have to add the base. So surface area is lateral area plus a base. So we know we have 45 pi so far. And then our base is pi r squared. So pi times the radius squared is 81 pi. So when we add those two things together, we end up with 126 pi centimeters squared. So those are your two answers. Cones are a little easier because there's less to find. This one, though, is about as hard as a cone will get because you need to find this L. You need to find the slant height. But they did a pretty good job of outlining the fact that this is a nice, pretty right triangle with one leg of 15 and one leg of 8. So use Pythagorean theorem to find that L. So we always do composite figures where we put more than one shape together and we got to figure out the total surface area for that. So when I look at these two cones right here, I have this cone and then this cone, and their bases are touching each other. So those bases will not count in the surface area. So basically all we need to find is the lateral area of both of these cones and add them together. So lateral area of cone number 1. Remember that lateral area is pi times the radius times the slant height. So since these cones match up together, the radius for both of them is 6, and the slant height for this one is 12. So we end up with the lateral area of this first cone is 72 pi inches squared. That's this guy here. So now I got to find the lateral area of the other one. And the formula is exactly the same, except it's not as easy because we don't have all the parts. We don't know this slant height here. But just like the last problem that I talked about, they made a nice, pretty right triangle here. So if we take this out and use Pythagorean theorem, we can find that length. So 8 squared plus 6 squared equals x squared. If we do some algebra, we end up with this being 10. So my lateral area here is 10 inches, or my slant height, sorry. Now to find my lateral area, I have to plug in my radius of 6 and my slant height of 10, and I end up with 60 inches squared. So now because we don't need either of the bases, because the bases are touching each other, all we got to do is add those two up. So we end up with a total of 132 pi inches squared. Make up those two cones. I'm leaving this one for you to give a try. It's a little bit harder, but we'll definitely go over it in class tomorrow. Effects of changing dimensions. So let's say the base edge length and the slant height of a regular hexagonal pyramid are both divided by 5. Describe the effect on the surface area. So if we're dividing these by 5, we're really multiplying by 1/5. And remember, if you change both of your dimensions this way, to figure out the change in area, all you got to do is square it. So the surface area will get 1/25 the original size. Remember, you can always actually do these problems and figure them out, but that is way more work than you need to do. So same thing with this one. They're multiplied by 2/3, so tell me how the surface area changed. I'm going to leave this one for you to do. Try it tonight, and if you don't get it, we can go over it in class. It helps to actually find a circle and cut this shape out and see what it means when it says this pattern is shown. The pattern shown is used to make a paper cup, and find the diameter of the cup. Make sure you try the ones that we left blank, because you should be able to apply the formula for the surface area of a cone and a pyramid. If you cannot, make sure you write down what questions you have, and we can go over them together. Enjoy your night.